In this podcast, we're going to be looking at the different properties of matter. We're going to be looking at physical and chemical properties as well as physical and chemical changes. So let's talk about properties of matter. We have physical properties and chemical properties. Let's start with physical properties. Physical properties is what a material looks like. So, for example, its density, its color, its texture, how well it conducts heat or electricity, whether it's bendable or not. Those are all physical properties. A chemical property is how that matter acts. So how new substances are formed. So does it burn? Rusting is an example. Reacting to light. Those are chemical properties. So physical property is what it looks like, and the chemical property is how that material acts. And it usually results in a new substance being formed. We can also look at physical and chemical changes. Now, a physical change is the change in the appearance of the substance, but not the actual substance. So, liquid water being frozen as ice or turning into liquid water or being water vapor, they're all water, but it's all physically different, but chemically it's still H2O, so that would be a physical change. Another example would be crayons. They're all crayons, even though the colors are different. That's just a physical change of the crayon property. Okay, and then a last example is wool. It's whether it's on the sheep or actually in a sweater, it's still wool. So the appearance has changed in all of those, but the actual substance itself has not changed. On the other hand, a chemical change is a change in the chemical identity of a substance. The atoms are actually rearranged to form something new. So an example would be iron that's exposed to oxygen. It turns into rust, and that is the new substance that's formed. Note some things that you would see, or something that's produced so that you know a chemical change is happening, is that there's an odor that's produced. You actually get a change in color, or a gas is formed. So that would be some things that you would see or notice so that you would know that a chemical change is happening. So for our properties of matter, we have physical and chemical properties, and then we can also see physical and chemical changes that occur as we're dealing with our different types of matter. Conservation of mass. We've talked about conservation before. In this case, conservation of mass says that matter cannot be created nor destroyed. So mass of all of the substances before the change has to equal the mass of all the substances after the change. So for example, if I would burn a log, the mass of my log before I burned it would have to equal the mass of the ash, the gas that's produced, all of the substances that are still left over. Those have to equal. So when you're calculating that, you actually have to take into account the oxygen and everything that's released as you're burning the log. You would actually have to capture all that gas and add that to all of the ashes that are there to make sure that your mass is equal. And the conservation of mass says that those things will equal each other, even though it doesn't look like the mass would be the same because you're just left with this pile of ashes. Conservation of mass says otherwise. The mass of all substances before the change will equal the mass of all of the substances after the change.